Thank you so much, everyone. It's great to see this nice group here today for the farming resilience, unlocking the Artemia opportunity. So looking forward to the next 3 hours to see how we can unlock this opportunity. Some housekeeping just to start the session today. So I think everyone knows microphone, camera off to avoid distracting the speakers. Very welcome to put questions in the chat, and that helps us organize the Q&A sessions. We've got 2 or 3 Q&A sessions, and hopefully we'll have some good questions, some good answers. So encourage everyone to put in the chat. It helps us organize ourselves, and you'll receive copies of the presentation after the webinar. So again, big welcome from me, Mike Phillips of Future Fish, and to start us off today, welcome remarks from Duka Castren. Big welcome. Looking forward to hearing from you. Thank you.
Thanks, Mike, and good morning, good afternoon, good evening, good night, whichever time zone you might be in. One of the perks we have here when you work in the bank is, in addition to having 11-hour work days and 7-day work weeks, is that we have a chance to meet either in person or virtually brilliant speakers, brilliant industry leaders, brilliant thought leaders, and community leaders, you name it. And I think this Artemia workshop today, or webinar today, is an example of those wonderful opportunities we have to learn from the real champions in various sectors, and this is a kind of something that we really appreciate. We really appreciate in our work community. And I have to admit that Artemia is something that when Harrison and the team started to work on it, I had to Google it. It's not something when I was studying forestry in the University of Helsinki that we learned about. And then I was okay. When I went to Wikipedia and checked, what is Artemia? It's a kind of 1/2 inch critter, and I was thinking that why? But then I learned more. Thanks to the team, I learned that it's basically a key ingredient of a $50 billion value system, or kind of ecosystem, food aquaculture ecosystem. And that's exactly what we do in the bank. We aim to find solutions and then scale them up. And I think the Artemia story is exactly a scaling up story that we want to learn from, we want to nourish, and we want to build on. And again, Artemia is part of an industry that is expected to generate 22 million new jobs by 2050, and it's the fastest growing food sector in the world. So it shows that even 1/2 inch small critters can play a huge role in solving global development problems. And this is a story that we want to learn not only in the aquaculture sector but also across sectors, because the point is that in the bank we increasingly aim to find smart solutions to the development challenges, finding ways to promote smart development. We know that Artemia production is challenged. Could somebody mute themselves? Harrison, I think it's you. Thanks. So we know that Artemia production is threatened by climate change. So therefore, we need smart development solutions to address that challenge to the industry. We know that there are hundreds of millions of youth entering the job sector in the nearest future, and we need to find jobs for them. And building sustainable aquaculture is part of that solution, part of the solution to that problem. And Artemia is part of that growing sector. So again, smart solutions for the jobs agenda. And then it's not only that Artemia production is challenged by climate change, but also increasing and improving the aquaculture value chains is definitely one way of decarbonizing, making a climate smart food systems. Again, finding smart solutions to our development challenges. So even if we are talking about a relatively small animal, it shows that by creating knowledge, sharing that knowledge with the global development community, we can address big development problems. And I think this workshop we are launching today, the Farming Resilience, Unlocking the Artemia Opportunity, is an example of exactly where the bank and the global community of practice, inside the bank and outside the bank, get together, finding smart solutions to development challenges. And I really appreciate everybody of you, the organizers, the speakers, the ProBlue Trust Fund that made all this happen, and then obviously all the participants. The screen shows that there are at the moment 50 participants, 50 people who have shown interest in this topic, and I'm sure more will join as you progress. So I wish you all the best, and thanks to everybody involved in this wonderful webinar today. Thank you.
Thank you, Tuukka, for those welcoming remarks. That was great to hear, and I love the smart solutions to development challenges. And I hope we're going to hear some of those smart solutions today, and I'm sure we will. But let me segue now to Ruth Garcia Gomez, who will give a little bit of the introduction to the work that's been done. A big thank you again, Tuukka, for the welcoming remarks. Now, over to you, Ruth. Thank you.
Thank you very much, Tuukka, and thank you very much, Mike, and thanks to all the participants, the speakers, and we all organizers of this webinar. Thank you, Vivek, for running the slides. As Tuukka mentioned, we are going to present today at this Learn Through event the key findings and most important take-home messages of an ASA that we have been implementing between 2024 and 2025 on brine shrimp and Artemia, which was named as a strategic approach to brine shrimp aqua business. And I'm going to show you very, very quickly some of the components and deliverables of this ASA and which we are planning for the next steps. Next, Vivek. Just to give you a little bit of overview or background, as you all know, the World Bank Group supports sustainable development of marine and coastal resources, not only aquatic, but also terrestrial associated resources with marine and coastal areas under different blue economy initiatives. Aquaculture, the farming of aquatic organisms, including crustaceans, seaweed, aquatic plants, bivalves, and finfish, plays a vital role in ensuring job creation, economic growth, food security, and livelihoods in marine and coastal communities. As you know, and I am pretty sure most of you know, in 2024, aquaculture accounted for more than 50%, actually 57% of the total seafood production. I mean, aquatic organisms production for human consumption. This doesn't include all the other uses of aquaculture, for example, for biostimulants, aquafeed, and so on. In Artemia, as Tuukka mentioned, it's a very tiny organism. It's a small crustacean that has been playing and nowadays plays a critical role in aquaculture. It has been actually one of the most important assets to promote and enhance the growth of the aquaculture sector in the past years as a live feed ingredient. It can also create a new income and employment in saline impacted regions all over the world. Next, Vivek. Just to give you a little bit of background on next. I don't know if we would change the slide. I'm not going to repeat what Tuka mentioned, but the relevance of Artemia is known all over the world. It's a highly nutritious crustaceans, mainly used for early stages of aquaculture development for the larvae stages, and it's supporting around 10 million tons of aquaculture production globally. Here I have shown a kind of a nice picture of a giant tiger brown, a Penaeus monodon, eating free swimming adult Artemia, which are the white dots that you can see in the picture. But apart from this traditional application or common application of Artemia as live feed in aquaculture, there are many others new and emerging applications that are going to be presented today at our webinar, and which has been the subject of our analytical studies and deliverables within this ASA, including possible uses of Artemia in the aquarium and pet trade industry, in different research and education options in pharmaceutical and biotech applications. We are giving a special emphasis to the production of Artemia as human food due to its highly nutritious characteristics, and also as a possible production system providing ecosystem services and being integrated with other industries, for example, with salt extraction. Next. The problem we are facing with Artemia, and this has been leading most of the analytical work of this ASA, is that 90% of the Artemia seeds are harvested and around only 10% are farmed, and most of the wild populations have stagnated. So in order to mitigate the risk of over-harvesting, we are looking in this ASA into sustainable farming practices, improving efficiency of utilization of existing stocks, and also alternative supply solutions. And most of these will be presented during the webinar today, with a special emphasis, as I said, in integration with salt extraction and different possible farming systems to enhance job creation and economic development. Next. And lastly, just to show you very quickly that this ASA, this strategic approach to Artemia aquabusiness, it's a development objective which is quite focused on improvement of knowledge of Artemia production value chain towards investment promotion, and it has been divided or kind of structured into different analytical work, which is explained in the table shown on the right side. These reports will be published very shortly for internal and external users. And during these months, we have been working on a global overview of Artemia production and conservation practices, a global market study, assessment and analysis of regulatory frameworks and governance, and governing Artemia production and conservation. And then in-depth country case studies on human food production and live feed, and a global inventory of technologies, stakeholders, innovators, and entrepreneurs, which is coming together with a database, an interactive database on these Artemia stakeholders. And finally, a synthesis report that is summarizing the key findings and major takeaways of these deliverables. Next. And just to conclude, next, Vivek. We are currently immersed in the next steps in the dissemination of these deliverables, in the dissemination of these key findings, which are relatively new also for the aquaculture industry. So we are working into different actions, including awareness raising, targeted regional and country actions, and also looking into business catalyzer on strategies. And as you can see today, also online presence in order to disseminate and share and enhance the knowledge towards Artemia production and conservation, as I said, not only for a live feed input in aquaculture, but including many other applications, new and emerging applications. So you will hear more from us. Thank you very much again for your presence today. I can see now 51 participants. This is wonderful, and I would like to give the floor to Mike. Thank you very much for your time, and looking forward to a very fruitful webinar.
Thank you very much, Ruth. And again, encourage. If you have questions, then please do pop them in the chat. Thank you for that. Now, I would like to move on. We have 10 minutes for a opening conversation. This is a virtual fireside chat between three key people. We have Harrison Charo Carissa, Senior Fisheries Specialist, Aquaculture at the World Bank. Welcome, Harrison. Professor Patrick Sorgelus, who I don't think you need any introduction, Patrick. When it comes to Artemia, everyone thinks of Patrick. And then Philippe Ledger, who was the former CEO of Inve Aquaculture, one of the world's leading Artemia-related companies. So over to you three you have 10 minutes of what I think will be an interesting chat. Who's kicking this off? Is it you, Harrison?
Thank you very much, Mike, for introducing us to the panel. Well, I'm really glad to have with me here these two legends, I will call them, and veterans. That's a word that I used very, very purposefully because of the experience that our two gentlemen here have. And my duty today is not to talk too much, it's to ask you questions and get good answers. Philippe Leger, for those who might not know him, because he's appearing here for the first time in our webinars, he is a PhD of applied biology called sciences, and he got this PhD in the year 1983. So these are really veterans. He has been working in very many areas, and I'm just going to ask questions concerning that experience in issues of Artemia for a very long time since graduation. And then Patrick Zoglos, as I said, I'm not going to pick something, but since I said he's a veteran and legend, I will tell you that he has been a professor at Ghent University for 54 years. So this is the kind of experience we are talking about today. And I just want really to draw a bit from that experience today. I will start with Philippe Leger with a question, basically trying to draw from your own experience. You are a veteran, as I just called you, Artemia specialist, both in R&D and business. You have done quite a lot. Your CV tells it all. And you have also been head of the Inve for decades. One can say that you have basically seen all that there is to be seen in Artemia production. Can you share highlights of your journey and how you see the future of Artemia from now going forward? Welcome.
Well, thank you, Harrison, first of all, for having me here. It's my pleasure. You were asking about my journey with Artemia, and that started actually in the late 70s. A journey that would not have happened if I have not met with Patrick Sorgelus. He was then teaching mariculture at University of Ghent. And those that know Patrick, with his energy and enthusiasm, he really got me fascinated in this new world of producing marine protein and the role that Artemia, with its unique biology, could play for making that possible. Then Patrick invited me one day to the Artemia Reference Center, and he suggested me to join the team and do a PhD on the nutritional value of Artemia cysts. It was so that in that period, the Artemia Reference Center, Patrick's lab, got many reports indicating very variable culture success using one Artemia versus another. So that was very nice to take as a subject for a PhD. And we studied many sources of Artemia and also different harvests within the same source of Artemia. And actually, within a couple of years, we were able to establish that certain fatty acids, the highly unsaturated fatty acids, really played a critical role in the nutritional value of Artemia. And on top of that, we could remedy that, correct that, by developing a procedure for bioencapsulating these molecules into deficient Artemia and therefore also improving their nutritional value. Honestly, my real interest, though, was to translate and to scale such scientific findings into more practical and effective solutions for the industry, aquaculture that was in development in those days. And that opportunity actually came quite fast, already in 1983, when the University of Ghent established a spin-off company called Artemia Systems. The mission of Artemia Systems was actually to valorize the expertise of the Artemia Reference Center. And in that period, I became responsible for the company's R&D. And at that time, we actually successfully pioneered the very first products and also practical methods for bioencapsulated or enriching highly unsaturated fatty acids in Artemia. And I'm proud and happy to see that bioencapsulation today is a standard practice in marine hatcheries. We also scaled and commercially introduced Artemia quality standards, because standards at that time were actually not established at all. The original standards at lab scale were developed by the Artemia Reference Center, and we were able to translate that in practical and usable standards in an industry where quality was actually all over the places. And using these standards now, most Artemia companies have been able to adapt and incorporate that in their business as well. A next highlight happened in the beginning of the 90s, 1991, when Artemia Systems became a part of the larger INVE group. At the INVE group, I was asked to head the INVE aquaculture business, and we got the opportunity to develop a full portfolio of both nutritional and health products, but with Artemia still being at the center of it all. I remember that our main challenge in growing our Artemia business was very soon to secure sufficient raw material, which became bottleneck. But at the same time, our strength was our product innovation capability. And actually, I can say with confidence that over the years, we developed the most innovative line of Artemia products then available. And we could do that by, in the first place, understanding Artemia's unique biology, but also, maybe above all, by listening to the farmers, understanding the needs of the farmers, what they were needing for actually using Artemia as a convenient source into their operations. And I'm happy to see that INVE as a company today is still spearheading this innovation of Artemia. Now, Harrison, you were also asking me the question how I see the future of Artemia.
That's correct.
I will present that later in the seminar, but as was mentioned before, Artemia is a natural product, and therefore supply is very dependent on what nature is producing. And unfortunately, nature has proven to be quite unpredictable, with times of shortages, but also times of oversupply. However, the current undeniable trend is that global Artemia supplies are stagnating, and I can say that's worrisome. It's worrisome because the industry that is driving demand of Artemia is aquaculture, and it's clear that aquaculture production is believed to continue to grow. The result is that already today, the market is forced to produce more shrimp larvae and more fish larvae with less Artemia. And obviously, this will aggregate in the future. The more so since it's clear, or it has become clear, that that the quality of the fry feeding on Artemia degrades when the feeding rates of Artemia drop below certain levels. Now, therefore, I think that efforts are really needed now, first of all, to make better use of the current Artemia resources, but secondly, also to secure more and more consistent supplies of Artemia. And I will go in a little bit more of detail further on in the seminar, Harrison, if that's okay with you.
Thank you very much, Felipe. I think you have nailed you have just said what I wanted to hear concerning the answer, the history that you have also brought in, and now that we are facing a future that requires more Artemia. Indeed, you are right. Mariculture is just beginning, and mariculture will be a very big consumer in many countries, that is, and it will be a big consumer of Artemia. We cannot afford not to have sufficient quantities of Artemia at this time. So this is a great journey, and thank you again for all the contribution you have done over the years. And really, I think you have very many breakthroughs that are very important for us today. I will not continue. I wanted to ask you another question, but I won't because of time. You have done very well on that answer, so I will let you off the hook now. And I will turn my face to Patrick. Again, another veteran. Patrick, you have also been working. In fact, I'm just, now I've learned from Felipe that you have been there longer than Felipe. And you have done all these things. And really, when they say you are the father of Artemia, that is the truth. You have been working with us now on this ProBlue funded Artemia activity. And, but you have been doing this thing for many years. You have had a lot. I just want to zero in on this ProBlue study and to see, did you learn anything out of this? Because, I mean, it wasn't really basic research. It was not even research at all, just a study to understand the dynamics of Artemia, the landscape, and so on and so forth. Is there anything that you actually learned that is new that you can say, I took something home with me?
Yeah, thank you for this question, Harrison. Many of you might be surprised, but I have learned a lot in the last months in getting involved in this study. And it has all to do with the fact that for the past decades, we have been focusing so much on aquaculture and all the things that Philip has been saying. And by the way, let me just make a small correction when you talk about the work that I have done. All what we have been able to accomplish is thanks to a tremendous teamwork all over the world, not just in the lab in Ghent, but I see here people from Brazil, from Iran, and others participating. It's thanks to them that we have made a lot of progress in aquaculture. But what I learned with this project is that we have to look further at the horizon of Artemia and realize that, for example, the way the economic studies have been done, what the potential is with Artemia biomass production, surprising figures about the cost of Artemia, we will hear later in the presentations. And then in particular, let's say initially linked with aquaculture, but the potential to produce and use Artemia as an animal protein, a protein that of course plays an important role in aquaculture, but that we can even consider as in particular regions in the world as a substitute for fish meal. And we will hear also from Manika in a while, even as an ingredient in human recipes. So thank you, World Bank. I have really learned a lot with getting involved in this study here. Thank you.
Thank you very much. And I really believe that our little efforts in working with you, at the tail end of, a lot of research that has been done, it will contribute more to the revamping of this sector and ensuring that what Felipe was talking about, we should be able to get more biomass of Artemia in the future. And I really appreciate again for all the good work you've done. We are all beneficiaries of the good work of these two gentlemen here, and I really appreciate it. Mike, we have taken a few more minutes from what we allocated us, but I think it was worth it. So back to you. And thanks again, Felipe and Patrick.
Thank you, Felipe, Patrick, and Harrison, for those insights that set the scene well. I think my job, according to the program, was to talk about the objectives and structure of the event. I think it's fairly clear in terms of the objectives that it's about sharing the findings from the ProBlue study. But perhaps more importantly, it's about looking into the future. And as Tuka put it at the beginning, smart solutions to development challenges. So how do we put the findings into practice? And I think all of us involved, and great to see Patrick so excited from the new things after many years of working in Artemia, is how to put the findings into practice. So we're really looking forward to hearing more about what was learned, but also getting feedback on what can do next, because we're all keen to put some key findings into action. So look forward to the feedback and discussion around that. And I think it's back to you, Patrick, now, for your global overview of Artemia production and conservation. I'll try to be a bit more disciplined with the time. I think we've got 10 minutes in terms of presentation there. So no need for an introduction. So I'll pass over to you for your really kick-off presentation. Thanks a lot.
Thank you, Mike, and hello, everyone. So Vivek, can I have the next slide? So next slide, yeah. So I will try to give a quick, I will try to stay within the time, and even if it can be shorter, I will do so. Next. For those of you who are not familiar with Artemia, let me briefly introduce. We are talking about the brine shrimp. And as all plants and animals, they have a Latin name, a taxonomic name, and this is Artemia. Artemia is best known for its cysts. You see about 0.5 millimeter in size. What is so unique about these cysts? Well, they contain a 4,000 cell embryo that can stop its development, that can be dried, that can be shipped around the world, and within 24 hours, you can produce an alternative for plankton. And this is exactly where the practical application came initially by the Japanese and then followed by the rest of the world. And of course, to produce these Artemia cysts, you see below Artemia biomass in the Petri dish. To the left, you see some 1 centimeter sized adult Artemia that can live in very extreme conditions, namely salt lakes and salt ponds. And in the next slide, I will explain about the life cycle. Next, please. The life cycle where we see that within 24 hours, we can have that magic powder, as I call it, converted into live plankton, which within a couple of weeks, depending on the culture conditions, you grow these 1 centimeter adults, and then you close the loop on top, the green colored one, and that means that the mother Artemia every 4 or 5 days in good conditions can produce over 100 offspring. In good conditions, you close this loop and you build a big population. When the mother animals get stressed, they produce these so-called cysts, the embryos that stop their further development in the cysts. Next. Where do we find Artemia? Well, the ecological characteristics, Artemia lives there where the others cannot survive. That means very high salinity. And in order to be able to live in such extreme conditions, well, Artemia has some very unique characteristics, a special osmoregulation system so that it can control the salt content in its body, even when it is living in very high salinities. It needs a way to better get oxygen through the hemoglobins. And then, as I mentioned it already, the dye-opposing cysts. Next. How does Artemia get from, let's say, from Peru to Ecuador, in Brazil, from one place to another? Well, the dispersion is mainly through these cysts. Birds, flamingos, and some other water birds play an important role. Cysts can stick to the legs. They fly a few 100 kilometers from Tunisia to France, and that's enough to get Artemia spread to different places. Over shorter distances, it can be wind. And then, last but not least, and this is, let's say, within the last 100 years, that man either undeliberate when they were transferring salt from one salt company or some place to another. And the other option is, as we will see, that people can introduce. Next. So where did it all start? So a little bit before the time that myself, Philip, and others started working on it, it was in the United States, the Steinhardt Aquarium, that discovered that using Artemia cysts from the Bay of San Francisco, they could produce food for seahorses. So a first company, San Francisco Bay, later another company in Utah, started to pack and sell Artemia, mainly for use in the aquarium hobby market. Next. The Japanese, as I mentioned to you already earlier, were the pioneers. It was mainly as of the 1970s. And in 1976, a very, very crucial year when, in fact, FAO was organizing its first technical aquaculture conference, and in fact realized that we might soon face shortages. And I had just finished the year before my PhD, and when you are young at that age and you are ambitious, you dare to say things in the United Nations conference that otherwise you would be a little bit more careful. So this is where, in fact, was good that the FAO was listening to the hypothesis that it was an artificial situation and that other sources and other activities could be explored to develop Artemia. Next. So a few years later, the Artemia Reference Center was set up at Ghent University. We immediately initiated, and that's where I refer to what I mentioned earlier, we immediately realized this is such a big challenge ahead if we want to see a solution for Artemia in aquaculture, that we launched the so-called International Study on Artemia. Many labs specialized in genetics, in nutrition, in others. And to the right, you see that over the years, a number of proceedings, conferences, manuals, FAO, and others were published. Next. So that resulted already within a few years' time to the availability of Artemia from different places in the world. And at the bottom center, you see there the Great Wall Chinese Artemia that already appeared in the market in the early 1980s. Next. In the meantime, techniques were further improved. You see here that we will hear more about the biggest industrial exploitation of Artemia on the Great Salt Lake. Next. And in Central Asia, the picture you see here, it's a lot of manual labor, but also to harvest huge quantities of Artemia. Next. So this is how, as we have heard earlier from Ruud, over the years, Artemia has played a more and more important role in aquaculture. In fact, being responsible today for over 10 million tons of aquatic products. Next. And we see the evolution here from a ton in the 70s to over 3,000 tons just since the last decade. Next. We will hear more about, and it was mentioned already, that 90% today of the Artemia cysts come from fisheries. Next. But it is good to see, and we will hear, that a lot of attention is being given to more controlled farming practices, be it in saltworks or in ponds, as we will hear in the next presentations. Next. 2010, 2020, everybody will recall, this was the year of the COVID, but that was also the time that in FAO headquarters, the aquaculture specialists couldn't travel and started to reflect on a number of issues. And one that drew their attention and critical dependence of Artemia was identified as a challenge for the future. So in 2021, this paper appeared where one was reflecting about how can we develop scenarios to ensure a more sustainable use of Artemia. Next. With a group of colleagues, and you see in the meantime the network of Artemia had really expanded. So the International Artemia Aquaculture Consortium was launched the following year. Next slide. The following year, it was recognized by FAO at the subcommittee meeting in Mexico. Next. And that allowed us, with a group of experts, with a group of experts. This is not the right presentation. Can you come back? Yes. So, as we have heard already, and we have seen that slide, it was through that International Artemia Aquaculture Consortium that attention was given. We need more work, we need more study, and it is thanks to the initiative of the World Bank that then the study was taken up, not limited to aquaculture, but as we see here, the different domains and particularly the economic potential with Artemia was being considered. Thank you.
Thank you, Patrick. Our next, we have two speakers next, Philippe, who will, I think, provide more insights into the market analysis of Artemia, and then my colleague Oleg Kaminsky, who was the Artemia project lead and colleague at Futurefish, will follow Philippe and talk more about investment opportunities emerging from the study. Thank you very much, both, and over to you, Philippe.
Looking at Artemia supply and demand, we should look in the 70s, early 80s, when there were basically only two major sources supplying Artemia cysts, namely the saltworks of San Francisco Bay and the Great Salt Lake in Utah. Customers at that time were mainly aquarium hobbyists. Unfortunately, harvesting from the San Francisco Bay area ended in the mid-80s over legal issues, leaving us only with Great Salt Lake as a commercial source. In the mid-80s, early 90s, when shrimp and marine fish aquaculture were developing, demand started to kick off, and several hundreds of tons of cysts were harvested and supplied from the Great Salt Lake. However, as of 1992, harvest from the Great Salt Lake decreased, and as demand for Artemia cysts started to exceed supplies, INVIT took the initiative of pioneering an exploration of new sources of Artemia for commercial exploitation by setting up an Artemia task force. For this, we worked together with the Artemia Reference Center and also local research institutes for ecological monitoring of the lakes in Russia, Central Asia, and China. Also, we started up commercial harvests at different locations, also with local entities. As you can see in this graph, the efforts of ATF came timely, as during the second half of the 90s, the majority of cyst supplies were harvested from the lakes in Central Asia, Russia, and China. This started with INVIT's discovery of a source in Turkmenistan that initially alleviated the shortfalling supplies from the Great Salt Lake, and that, along with Chinese product from lakes and salt lakes for the local market, and growing supplies from Siberia. In the meantime, the Great Salt Lake harvest experienced a second significant drop in production towards a record low harvest in 2000. Fortunately, after the year 2000, the Great Salt Lake harvest recovered, especially after the setup of the Great Salt Lake Brine Shrimp Cooperative in 2007. Since then, average yearly harvest from the Great Salt Lake doubled from about averaging 700 tons to over 1,400 tons. Also, more natural lakes came gradually into production in Russia, Central Asia, mainly Kazakhstan, and China. And since 2007, average global supplies of quality Artemia cysts for aquaculture hatcheries exceeded 3,000 tons annually. Currently, global cyst supplies average about 3,500 tons of good quality cysts. Now, talking about demand and demand outlook, we can say that for growing shrimp and marine fish fry, Artemia nauplii are still considered as the most convenient and nutritional food source. As this graph shows you, you see a presentation of the volumes of Artemia of cysts used in the most important shrimp and marine fish markets, with the largest ones being China, Ecuador, and India, together consuming about half of global supplies. Now, with global aquaculture of shrimp and marine fish expected to grow at around 2% to 6% annually, we anticipate that global Artemia demand is expected to exceed 5,000 tons in less than 10 years. And therefore, we would need the equivalent of another Great Salt Lake. But as we know, global supplies have largely stagnated, and the shortfall is not likely to be filled with a new large natural source anytime soon. We have also experienced in the past that procurement issues have been a direct driver of pricing pressure. And that brings us to price dynamics and supply chain challenges. The best understood factor affecting price is cyst quality. For example, Artemia cysts with a hatching rate of 90% will be triple the price of a product of 50%. Also, a small strain of Artemia cysts with highly unsaturated fatty acid content may cost more than double the price of a regular one. Also, added value Artemia products may command a higher price. For example, cysts with better separation characteristics or better sanitary quality, or Artemia offered as a ready-to-use live nauplii paste instead of cysts. Another important factor affecting cyst price has been its supply and availability in the market. Global supplies have stagnated. However, year-on-year variations, like you see here, have had a significant impact on pricing. For example, in the late 90s, when the harvest went down 3 years in a row, Artemia prices had doubled and relaxed when harvest volumes came back into the market. Now, year-on-year variability in production of Artemia in natural lakes is often caused by ecological changes. For example, changing salinity in Great Salt Lake by less or more inflow of river water, or changes in salinity in the Karabogaz Gulf by changing levels of inflow of Caspian seawater, making the resource to rise, to produce, and to go extinct. Also, man-made changes in salinity caused by cutting off water inflow from rivers altogether, like at the Aral Lake, were first generating considerable harvests that are now on the decline. Sadly, at present, there is no known Artemia resource of sufficient size to meet the growing global demand. Now, how can we cope with this supply challenge? First of all, at the source site, we should promote and adopt sustainable harvesting practices everywhere. Taking the example of what happened at the Great Salt Lake, or even the quota system in Russia, and at the same time also dealing more effectively with poaching activities. Also, one should continue the Artemia task force efforts in exploring and monitoring natural salt lakes, as all of them undergo changes and new sources may arise, others may disappear. Thirdly, we should look at adding supplies through controlled production in salt works, like, for example, in China, producing hundreds of cysts per year. That could be copied in big-scale projects like in the Emirates, in Samasalt, or in smaller projects like in Cox's Bazar, Bangladesh, and also in dedicated ponds for the production of small Artemia cysts like in Vietnam. Also at the user side, options are available to do more with the current available supplies. First, we should be using the current supplies more efficiently through better hatching practices or through enrichment techniques, or by using lower hatching grade Artemia hatched into nuclei by dedicated companies selling them as a paste, or produced in-house by larger users with specialized product and equipment. Now, already for years, the use of Artemia has been significantly reduced in best balance with performing replacement diets. But one should keep in mind that feeding too little Artemia will affect hatchery success and affect output even in the farm. That has been proven. In conclusion, we can state that efforts are required now to better use the current Artemia resources and to secure more consistent supplies of more Artemia. Thank you.
Oleg, over to you.
Hi there, my name is Oleg Kaminsky. I'm the project lead at Future Fish on the World Bank and Pro Blue Artemia study. So I'm going to talk today, moving from what Philippe said from wild harvests. We're going to talk just quickly about farmed Artemia supply, and later you will see another presentation where I get into the specifics of some of the models and the investment cases, and you'll hear about some of the case studies. But for now, I'll just try to contextualize what Philippe talked about in the context of farming of Artemia. So you've seen now that there's been quite a shift from wild fisheries. Commercial harvesting of Artemia cysts began in San Francisco, and that moved on to early farming in the Great Salt Lakes and in different parts of China and Thailand. There was some supply volatility in the 90s, and this initiated the Artemia Task Force, which then looked seriously at farming as an alternative to wild harvesting. And then in about 2000s and 2010s, it started to intensify and grow. And today we have quite a bit of farming, but really only in 3 countries. And so we still see that the vast supply of cysts in the world are coming from the wild, and only about 10% come from farming. So if we break this down, the cyst market a little bit, we see that overall there's roughly 3,800, maybe around 4,000 plus tons, depending on the year. And almost all of this goes to aquaculture feed. 80% goes to shrimp, and about 20% goes to mariculture of finfish. And then small amounts go sometimes to Nigeria if there's surplus for catfish, for example, or different countries in Africa might import a little bit for some shrimp in Madagascar and so on. But largely, these are not consistent supplies. So of these cysts, as we said, 90% is harvested basically from 4 or 5 countries, the USA, Russia, Uzbekistan, Kazakhstan, and then from China as well. And China farms the remaining. So the 10% that's farmed cysts, 90% comes from China. So they're producing roughly 400, 500, 600 tons of cysts, depending on the year. So a very small amount comes from Vietnam, only about 30 or 40 tons of cysts. However, those cysts are some of the most high valued cysts in the world. And that market alone is worth probably around $6 million, $4 to $6 million, and provides jobs for over 2,000 people. So we see that specifically these cysts are being used for shrimp and crab, and some finfish species like yellowtail grouper and so on. And we're seeing, however, that there's a gradual increase of farmed products in localized areas, which is still small, but disrupting parts of the cyst value chain. If you look at biomass, it's a little bit different. So biomass at the moment is treated in areas like India, where it's harvested almost like a byproduct of big salt pans or the solar salt industry. In China, it's farmed, but it's still found mostly in the solar salt production. So almost all of it right now that's farmed is coming from China, roughly just over 100,000 tons. Here you see a picture, for example, of biomass that's being processed. Biomass right now is going and being used directly, almost exclusively in China. Very small amounts actually in Iran and France as well. But in Thailand, although only produces maybe 200, 300, 400 tons of biomass, is being done in intensive farm systems. You'll learn about some of these later. And these go directly into localized hatcheries. So it's fed as live biomass directly into hatcheries, and you see that in shrimp and prawn, crab, lobster, and a little bit in some marine fish nurseries as well. So this is sort of, instead of importing cysts and hatching them, people are starting to farm biomass and selling it directly, mostly as a live feed into certain hatcheries, but there's also greater potential for processing, for making pastes, for freezing it, for transportation to greater areas. We're seeing in Uzbekistan some farmers experimenting with being able to grow biomass as well. So the biomass market is probably the most interesting from the farming perspective because it's pretty low cost, low input. You can produce biomass in Thailand. They're producing it for 15 US dollar cents a kg, which is very comparable to other sources of fish meal. And so we're seeing right now this slight change. It's still mostly only really in 3 countries, which is China, Thailand, and Vietnam, where we're seeing these changes in the supply chain from the farm cysts and biomass. A little bit of experimentation in Bangladesh and a little bit in Kenya as well. And you'll learn more about this later on today. So the supply is starting to shift and change, but there's still a long way to go for farmed products, farmed Artemia products to really take hold. So even in China, even though they're farming cysts, they're still importing a lot of cysts from the US and from Russia and from other places because it's still relatively cheap in certain, depending where you're importing from. So Central Asian cysts are, for example, a bit cheaper than the Great Salt Lake cysts. And so even though Vietnam is farming cysts, they're also importing cysts. So there is still a deficit there that needs to be filled. But at the quality of what they're farming, and because it's higher price per kg, that price point there is where the challenge will be mostly for farmed products. So, okay, we've seen that the wild harvest cysts have been sustaining the aquaculture sector, primarily the shrimp sector, for decades now. But we're seeing a change also in some of the alternative proteins that are coming into feeding fish as well. And so rotifers and copepods and different algae and spirulina and insect meal, and so on. These are sort of the places that Artemia is mostly competing against. And so, for example, in carp, there's some really good studies that showcase that feeding biomass, feeding Artemia to carp larvae is a great is quite an efficient source of protein. But there's also many carp farms that use rotifers that are almost free in many cases. So finding that balance and the localized sources of protein is really the biggest challenge here. And so if we look at some projections, and we'll dig deeper into this later on, but if you see that aquaculture is growing and Artemia trade is expected to grow to even close to $600 million by 2035, this will require an almost 40% increase on cysts and biomass, and this might create a pinch point and an inflation on the cost of cysts that could rise by even 30-50%, which would then constrain the market, especially in emerging markets, will constrain the hatcheries particularly. But we also know, as we've seen from Philippe, that the supply from some of the lakes is dropping. And so every year a 1% drop could translate to even $2 to $3 million because the price of the cysts could go up. So these environmental stresses could ripple through those hatcheries. And if you still see that most of the world's hatcheries, most of the world's cysts that supply hatcheries like shrimp come from about 5 countries. Those 3 of those countries, the lakes, are running out of water. And so we're seeing a crucial move to try and find where farming will take place, fit into the value chain. It won't be a replacement. They have to work together. There will be harvested cysts always, and there will be a space for farmed cysts and farmed biomass. Looking at export markets and prices and transportation, it might be better in some cases to grow localized biomass sources directly for hatcheries rather than importing them. But again, this will depend on the type of hatchery and the type of market. So there's, as we said, there's lots of competition there. But there's alternative markets, for example, that you can look at poultry, you can look at the human food potential. So you'll see some of these discussed today. But just a 10% shift from wild to farmed Artemia could unlock about 50 to 70 million US dollars and create 15 to 20,000 coastal jobs just in biomass farming in artisanal salt systems. So if biomass is used even as a 5 to 10% fish meal replacement, it could yield $150 million feed ingredient market. If you look at the potential for high quality decapsulated cysts, hydrolysates, enriched powders, ready to hatch pastes, all of those kind of products that can be processed, then you're looking at growing markets that could reach huge potential by 2030, especially if the supply from lakes keeps going down. So just as an example, in Africa, if you took 20,000 hectares of underutilized salt or saline areas and turned them, or salt ponds like we see in Senegal, for example, you could yield about 1,000 tons of cysts a year, which is equivalent to about a $50 to $80 million industry. So when you look at it this way, we need to find the right place for farming, and later you'll see the different countries and different areas and different value chains that we've explored to try and find investable, scalable business models for Artemia farming. So thank you very much, and we look forward to the rest of the session today.
Okay, thanks a lot, Oleg, and yeah, I appreciate that. And those sort of new areas of Artemia for utilization in terms of human food and animal nutrition beyond what we're doing already with Artemia is really exciting. New frontiers. We've got 2 presentations on that. Fascinating to learn about the market dynamics and that push into the future of both conservation of the wild, but the the need for another Great Salt Lake to produce enough Artemia, and the push for more production is through aquaculture is also coming through very strongly. So thank you. Now, again, I'd encourage questions in the chat. We're going to be a little bit tight for questions in this first part, but we will have some later in the session. As I said before, one of the exciting parts of the ProBlue study was actually new frontiers for Artemia production, particularly in human and animal nutrition. So we have two speakers, Manika Saha and Kartik Barua, to talk us through that. Manika, may I ask you to go first, please? And I think, again, Vivek is running the slides. Big welcome. And Manika is a public health nutrition practitioner currently based in Australia, and brings an important human nutrition thinking to the whole question of Artemia and its role in not just animal, but human nutrition. Over to you, Manika. Thank you for joining today.
Thank you, Mike. Thank you, Mike, for the introduction. Hello, everyone. My name is Manika Saha. I'm working as a research fellow at Monash University, Australia at the moment. Today, I'm going to, can you please, next slide. Yeah, thank you. Today, I'm going to present a timely and underexplored opportunity, the potential of Artemia as human food. Next slide. Yeah, so why Artemia, right? So firstly, it's incredibly nutritious, high in protein, micronutrients like iron and zinc, and fatty acid, essential fatty acid like omega-3 and omega-6 fatty acids. Second, it's really cost effective. 1 kg of Artemia can actually cost as little as $1 US dollar, and just 16 gram of Artemia is enough to make a kind of one protein-rich kebab, like a meal. And third, it's very Artemia is scalable. For example, a hectare of pond can produce approximately 2 to 4 tons per month, and it matures really quickly in 2 weeks. That's actually compared to several months of years for fish, poultry, and cattle. And obviously, finally, it's the climate resilient. So Artemia can actually thrive in really saline and degraded and drought-prone lands, places where traditional agriculture really struggles. So all of these reasons, we actually argue that Artemia is really cost-effective, scalable, and climate-resilient nutrition solution for at this moment in the world. Next slide, please. So this is a nutritional composition of Artemia. It's from Lager et al. Lager is with us. So this composition is actually showing how Artemia is really nutritious in terms of macronutrients, including protein, lipids, as well as carbohydrate. And it's also really rich in micronutrients like iron, zinc, other vitamins like vitamin B, B12, for example, and fatty acid like linoleic acid, omega-3, and omega-6 fatty acids, like omega-3 eicosapentaenoic acid, and omega-3 another docosahexaenoic acid. Next slide, please. But it is also really important to note that the exact micronutrients and fatty acids such as omega-3 and omega-6 content in Artemia may vary on different factors such as their diet, environmental conditions, and specific species. And at the moment, current data in this area is really limited. Next slide, please. Yes. Artemia contains significantly higher protein content, like around 60 gram per 100 gram dry weight, compared to commonly consumed fish such as tuna, shrimp, tilapia, salmon, and cod. which is, you can see like almost like double most of the fish species mentioned in this graph. Next slide, please. Yes, thank you. We have also tried to see a similar kind of fish-based product and similar ingredient of Artemia-based product and the nutrition composition between these two. We compared with fish chutney and Artemia zolferaceae. Almost their recipes used similar kind of ingredients, and we found that Artemia-based Artemia zolferaceae has more macro and micronutrients, like rich in protein, fat, carbohydrate, and the micronutrients like very rich in iron and zinc, high in iron and zinc, as well as Artemia zolferaceae has high content of EP and DHA content that is really missing in fish chutney. Next slide, please. Now that, Artemia may sounds new as human food, but it actually has a fascinating global history as human food. Indigenous peoples around the world, including Great Salt Lake in US and the Plateau in California, even some areas in Mexico, Libya, and Iran, communities near, for example, Namak Lake, used to have consumed Artemia traditionally for a long time. More recently, in Vietnam and Bangladesh, have tasted Artemia different dishes, including Artemia omelets, Artemia kebab, Artemia sauce. So there are some pictures of the recent trials in those countries. And Artemia also tried as an Artemia seasoning powder in Vietnam. Which is really high contents of protein powder and could be used in where population with high protein demands. One interesting thing is there's a misconception that Artemia might be very salty because the thinking is behind this because it grows in salinity, high salinity. It might hold lots of salts inside it. But interestingly, Artemia is an osmoregulator, which means Artemia has a really nice mechanism in their body. They can maintain their body fluids at a salinity, and ionic composition actually really similar to human blood. So by simply washing it, we can actually, the Artemia can be prepared ready for food production, food-based preparation for human food. Next slide, please. We have also tried to see how what are the potential for Artemia and how can contribute in first 1,000 days of life, which is from pregnancy to when a child is 2 years old. So we found that Artemia can contribute immensely for nutrition nutrition enhancement, like just 30 to 50 grams of Artemia can meet over 100% of daily protein for infants and toddlers. You also see some micronutrients as well, like really high in iron, zinc, and omega-3 fatty acid that can contribute to toddler and infant nutrition, like more than 100% per day. And for pregnant and lactating women, these Artemia can also contribute, offer a rich source of protein, iron, calcium, iron and vitamin B12, which making powerful nutrition ally during the first 1,000 days of life. Next slide, please. We argue that Artemia can also contribute as a rapid nutrition solution. For instance, calculated like 1 hectare of a pond can produce 2 to 4 tons of Artemia biomass per month. If we think that we have like produced 2 tons of Artemia in 1 month, that means the same amount of Artemia can help us to produce Artemia-based food products like Artemia kebab, around 125,000 kebabs, which needs like per kebab is 60 grams of Artemia. approximately need for making 1 kebab. That means like if a family of 4 people needs like 240 kebab per month to meet their protein needs, around 32% of their daily recommended protein. So that huge amount of 2 ton, if we can think about, we can actually cover meat protein protein for like around 500 families, which is around like 2,000 people for an entire month. Next slide, please. We also try to see like how Artemia can contribute to the existing food products, like easily, because Artemia is a really like a shrimp, small shrimp, it's called as a brine shrimp. So similar kind of shrimp-based product can be, we can replace with Artemia, or we can actually supplement with the shrimp to make it more like with similar flavor and taste. For example, here are some examples from Asia-based food products like fish sauce, shrimp paste can be also produced like Artemia sauce and Artemia paste. These are the foods like Asia, really popular in South Asia, including Thailand, Malaysia, and Indonesia, and so on. Next slide, please. Here are some examples for like how Artemia can also contribute in existing African-based food products, like where shrimp is kind of a important ingredient for that recipe, those food products, including like jollof rice, river shrimp stews, and so on. And seafood curry as well, we can try with Artemia curry. Next slide, please. We can also try Artemia in Western-based food products, including like Artemia burger, sauces, and nuggets, where we can actually replace or actually combine Artemia with the existing meat or shrimp, so that it can actually offer us an alternative traditional meat-based product, as well as highly nutritious, as well as we can make it most cost-effective food product. Next slide, please. Here are some strategies that we can think about to enter Artemia as a food-based food product, like for market growth strategy. To enter the market, for example, I have shared here 7 kind of strategies, but Artemia can be introduced as a nutritious and cost-effective alternative or supplement of shrimp in familiar products, like maintaining similar taste and textures. Collaboration with food manufacturers can help to integrate Artemia into existing shrimp-based food lines. We also position Artemia as a premium ingredient in functional foods such as protein shakes, health bars, and capsules. Additionally, can be introduced to ready-to-eat RT brands and convenience food market. So there are plenty of opportunities we can actually introduce Artemia in the market strategy. Next slide, please. This is the last slide. To contribute human nutrition, Artemia can play a role immensely. So, but we are really far away from that one. So at the moment, here are some recommendations, but we can go there if we can do more research and more investment in Artemia-based solution for human beings, doing more nutrition research, food safety, toxicology, more product development, and doing some cultural integration, piloting in different countries to see how it works, as well as like more interdisciplinary studies to see how it works and how can we make it happen in real existing market, as establishing Artemia as a human food. Yeah. Thank you. In summary, Artemia offers a really cost-effective, scalable, and climate-resilient food solution. Next slide. Yeah.
Right, thank you.
Thank you.
Thank you very much, Manika. And that was, I think that research was really eye-opening for me when I first saw it. That not only can you produce efficiently Artemia in salt impacted and very marginal lands, but it's a efficient protein supplier that is nutritionally very valuable for humans. So a really important frontier to explore. So thank you for introducing that. And animal food is another frontier, and I'd like to ask Professor Kartik Barua, who's head of Artemia Research Lab at the Swedish University of Agricultural Sciences, to tell us about his research on use of Artemia for animal nutrition and another frontier.
Hello, greetings to everyone. So my name is Dr. Kartik Barua. I'm an associate professor and head of the Artemia Research Lab at the Swedish University of Agricultural Sciences. Thanks to the World Bank as well as to Future Fees for inviting me to give a talk on this interesting topic, and that is the application of Artemia in animal nutrition. So when we talk about animal nutrition, the first thing that crosses our mind is the feed and the feed ingredients, of course. Why feed? Because that is the major cost of the farming sector. It's around over 60%. And another angle is that, or another reason is that, because there is quite a lot of demand or interest for finding novel ingredients for producing high quality feed. Feed ingredients that are high quality to produce high quality feed. There is also, we have to make sure that this feed or the novel or the feed ingredients that are being used in making feed, it has to come from a sustainable source. So we have a sustainability angle there, of course, with low ecological footprint. And there is also an increasing focus on the regulatory compliances. So the feed ingredients that we use to prepare feed, it has to have it has to meet certain requirements, because at the end of the day, all those ingredients or the fish or poultry, it ends up with the human food. I would like to walk you through the different generations of feed and feed ingredients. The first generations, these are the conventional feed sources like the fish meal and the fish oil or soybean meal. Second generations, these are the ingredients that are coming from known food or bioproduct sources like the rice bran or the insect meal and so on. And the third generations are more like a future feed ingredients, which are the ingredients that are genetically modified ingredients or the lab-grown meats. But as I say, these are more future-oriented feed ingredients. Why I'm talking about the different ingredients? It is because we would it's a very important question, and that is where to position Artemia in these different generation feed ingredients. I don't have a clear answer as of now, but I hope at the end of the presentations we find an answer to these questions about where to position Artemia in the feed ingredients the category. My colleagues have already given a very good presentations on the importance of Artemia meal, how nutritionally they are balanced. So what I try to do is to compare the nutritional compositions of Artemia with other different generation feed ingredients basically. And what we found is that if you look at the good protein content, you see here the Artemia meal, they have over between 50 to 55% crude protein content, and they are at par with soybean meal, insect meal and or single cell protein or the microbial protein. And in fact, compared to the soybean meal, it is higher, of course, lower than the fish meal. But if you look at the lipid content, the Artemia meal stands quite tall when it comes to the lipid content, which is quite interesting. Nowadays, there is an increasing interest in developing, most countries basically are trying to develop feed based on local ingredients, so that they can cut down on the carbon footprint, they can produce more and more sustainable feed, the quality can be controlled. So if we like to position the Artemia as a feed ingredients for animals, then you have to see the distributions of this Artemia. And as you can see in this slide, that basically the Artemia is distributed globally. And as Patrick mentioned, that these have been done by the birds, the flamingos, and thanks to those flamingos that they have distributed this Artemia in different parts of the world. So what I mean to say from here is that basically they are available in different parts of the world. If I want to zoom in to Africa, basically, and as you can see that why Africa, because aquaculture is booming there, the animal farming sector is booming there, so you need to have more and more protein source to feed the animal farm animals. So you see that Artemia there is a lot of Artemia activities going on in many different parts of Africa. So that's a good thing. And in addition to that, I would like to also say that, as many of my colleagues mentioned in their presentation, that Artemia can be found in places where other animals are not found. For example, in hypersaline lakes where other animals cannot grow. So basically, we can harvest those salt lakes or hypersaline environment and collect or protein to feed the growing population, basically. So in addition to this monoculture, basically, if you culture anything in those hypersaline, I call it like a monoculture. But it's interesting to tell you that or say that Artemia can also be integrated with other farming sector. How? And you can see here, this is a very good review paper where they have shown that basically the waste that are being generated from the farming sector, like from the poultry or shrimps farms, those wastewater or agricultural waste can be used as a resource for producing Artemia biomass, and more in a circular economy approach. This is quite interesting, especially in today's situation where resource is a big issue for us. And of course, waste is also a concern from environmental pollution point of view. So that's the good thing, that Artemia can be integrated with other farming sector. In addition to that, I would also like to highlight here that Artemia has a very interesting component or element in their skeleton or in their body, and that is the chitin. And these chitin are a digestible chitin, unlike other animals like crabs or shrimps. The Artemia chitin is quite digestible. And as you know, that chitin is a strong source of nutraceuticals, meaning that it can have some health or pharmaceutical impact. So this brings me to the next slide to tell you that basically Artemia is actually can be considered as a nutraceutical ingredient, and that's where it makes it a bit unique and a bit different than the other conventional or non-conventional ingredients, because it can offer the nutritional benefit, but it can also offer the pharmaceutical benefits. And obviously, I would like to support what I said now with some case studies, and I want to share with some interesting results. This is a work conducted by a group in Iran, and what they have done is that they have replaced fish meal with an Artemia meal at different inclusion level, and they have fed this to the broiler chicks. And obviously, as I say, that it is very important before introducing a novel feed or feed ingredients as an important ingredient in animal feed, we need to first check whether they are digestible or not. And this group has tested that. And here you can see here that the apparent crude protein digestibility of Artemia meal is over 85%, which is quite interesting, I would say, here. And also it has quite an interesting amino acid digestibility. So that was very interesting. This is a group again in Iran. They have tried to they tried to basically develop two different feed ingredients. One, they have used Artemia biomass that are collected from bone, and Artemia biomass, another Artemia biomass they have collected from the nature, that is from the Urmia lake. And they have replaced the fish meal at different inclusion level, 25, 50, 75, and 100. And they fed it to the broiler chicks, to the growers, as well as to the finisher, the broilers. So basically the whole chain, the culture period, basically. Sorry, the culture period, not the whole chain. So, and they found that even if you replace fish meal with 100% Artemia meal, there was no negative impact on the growth. In fact, the growth was obviously no significant increment, but at least there is no decrease. So that's a good sign that you can basically replace 100% of the fish meal with Artemia meal. Here in this case, you can see that they have used the Artemia meal that's harvested from the Urmia lake. And here again, even if they replace 100% of the fish meal, they didn't find any negative impact on the growth. On the contrary, at 50%, there was an increment in the growth of the broilers, which is quite interesting. So now let me take you from the terrestrial animals to the aquatic animals. And this is a study carried out by a group in Vietnam. And they found that basically what they have done is that they cultured, they produced this Artemia biomass from shrimp waste and used that biomass to make Artemia meal. And they replaced the fish meal with Artemia meal at different inclusion level, 10, 20, 30, and 40. And they found that the shrimp PLs, the survival was in fact better compared to the animals that were fed only with the fish meal. At 30% level, as you can see, that there was a significant increase, around 10% increase. And when they also checked the survival together with the biomass, here again you see that the animals that received Artemia meal, they had more biomass there. So this is quite interesting. So basically, I would like to say there is some nutraceutical impact going on there, because you have some positive impact on the survival and positive impact on the growth. So this is how I would say that there is a nutraceutical impact on that. Well, we obviously, when we talk, when we want to position an ingredient as a feed ingredient, we need to do the cost benefit. And I have been discussing with different feed companies, and this is how, when you wanted to prepare a feed, you need the major ingredients and the micro ingredients. You also add additives because of intensive farming system. A lot of farmers or companies use additives, and these additives are an extra cost. So when I was talking to these the different feed companies, from small scale to even big companies, they say that it's always the cost. If you want to introduce Artemia meal, for us it's fine, but it has to be realistic cost-wise. So I tried to do some cost analysis on a weight basis, and I found that fish meal is coming to somewhere around 1.6 USD per kilo, whereas the Artemia meal is less than $1 per kilo on a dry weight basis. So basically, there was an advantage of using Artemia meal there. And another point that I would like to say is that basically there is an advantage that Artemia meal is Artemia is more a carbon neutral, because it can be cultured on a waste ingredients, or it can be they are also available locally. That's also the good thing. But what is interesting is that because it is a nutraceutical ingredients, basically we can cut down, or if not entirely or partially, we can reduce the additive, the addition of additive in the feed. And because these additives are also cost, so we can cover up for the cost of this feed additive. And basically, we can also develop more from an ecological footprint point of view. We can produce more sustainable feed. But obviously, we need to do more and more lab-to-land studies. But As a home taking message, I would say that Artemia is far more than just a protein. In fact, it is a nutraceutical ingredient that has benefits beyond nutrition. And we strongly believe that this will support our sustainable feed solutions. It can open opportunities for employment, for new opportunities for markets, and at the end of the day can contribute to a more required resilient food system. Thank you very much.
Well, thank you, Kartik, and that emphasis on nutraceutical is really important, right? So excellent, and a good, I think a good close there. And let's we're going to try to keep some momentum, catch up a little bit of time, but we are collecting some good questions here, so we'll come back to them a little bit later in the program. Simon Wilkinson, we'd like to hear from you. Talk about the inventory. And Simon manages the information and networking for the network of aquaculture centers in Asia Pacific, or NACA, well-known intergovernmental organization based here in Bangkok, with secretariat here in Bangkok, Thailand. Simon, over to you. Thank you.
Okay, thanks, Mike. Next slide, please. Thank you. So this presentation concerns the global inventory report of Artemia stakeholders prepared as a component of the project under the World Bank Group ProBlue. This report provides an inventory of innovators and companies involved in farm production of Artemia globally. The overall goal of the inventory is to facilitate investment and innovation in Artemia production and conservation, focusing on both human food and aqua feed production while considering the environmental, social and economic sustainability avenues. Next slide, please. The content of the directory is designed to assist World Bank Group client countries, task teams and private investors to quickly search, learn, make contact and apply Artemia production technologies and innovations. The goal is to raise awareness of what's going on in the Artemia ecosystem and what's available, to facilitate informed decision-making by stakeholders and to identify contacts to promote the development of partnerships and investment in client countries. The inventory is not a narrative report. The core product is structured as a directory designed for rapid lookup and filtering with concise, standardized entries that you can rapidly sort and then move straight on to outreach. So practically, it's a who to work with map: producers, processors, traders, hatchery supply, research, industry associations, and financiers tagged by what they do and why it matters. The report will be made available as a standalone document, but the core directory content is also available as an online database, which we will see shortly. Next slide, please. The inventory was developed using expert knowledge from the International Artemia Aquaculture Consortium and consultation with industry, trade networks and researchers. Data was also gathered from a survey of aquaculture-related websites and trade publications and from local experts through a series of regional webinars and workshops conducted by the Artemia Consortium between 2022 and 2024. Data from these sources has been validated to provide up-to-date and verified information to support investment, innovation and development in the farmed production and conservation of Artemia and also Artemia-based products. Next slide, please. The scope of the inventory is global. Of course, the industry is not evenly distributed, but the report covers both major producing countries as well as emerging countries where there are opportunities for growth and where Artemia can support the development of other businesses such as aquaculture. The inventory report includes profiles of different stakeholders from farmers and harvesters to research organisations and financiers. Stakeholders are categorised by region, state, sector, business interest and innovation area. The scope of the inventory includes innovators of methods, technologies and products that enhance efficiency, solve problems, and create new opportunities. And they range from production of specialty cysts with unique characteristics to new applications of Artemia and improved farming methods. Beyond farm output, entries capture where organisations touch conservation, livelihoods, gender and youth engagement, and market development. Integration points such as solar saltworks or land-based mariculture opportunities are included, as these offer ideas and opportunities for scaling up or for creating new businesses. Next slide, please. So who is included? The inventory covers the main producers and traders of raw cyst materials, as they are still keystone players at this point, but the focus of the inventory is primarily on Artemia aquaculture and the value chain. So the inventory covers producers, but also post-harvest processing, hatchery technology, larval enrichment, harvesting equipment, research linkages, industry associations, as well as those investigating the application of Artemia cultivation in livelihoods, gender and youth engagement, and human food applications. Next slide, please. Contacts have been indexed to facilitate rapid search, discovery and understanding of information, and contacts and innovations are indexed by criteria including country and region, the industry sector, such as whether they're a farmer, processor, trader, equipment vendor, feed manufacturer or hatchery, their specialised area of business interest, such as human food, aquaculture, feed, salt production, economic sustainability, processing technology, conservation or youth. The innovation area, such as farming systems, enrichment diets, alternative feed ingredients, specialty cysts and live Artemia products have been added as an additional criterion. And where there is a focus of an entity on gender and youth issues, these have been included as an indicator of social innovation. So these are the fields that power the search experience in the online version. The taxonomy you see here maps one-to-one with the filter set. So you can start broad and then narrow your search to the exact combination of roles you need in your target geography. And on the right, you can see a brief shot of the online version at the moment. And next slide, please. The report also includes an innovation profile section that showcases advancements in the Artemia farming systems, as well as advances in technologies for hatchery production, live feed, and value adding. Each profile highlights specific systems, tools, methods, or products that have demonstrated improvements in production efficiency or nutritional quality. These innovations address key challenges in Artemia cultivation and use, providing practical solutions to enhance the reliability and performance of production systems, and they serve as a resource for understanding how targeted interventions and novel methods can contribute to improved outcomes in Artemia farming and its applications in the hatchery or in contributing to rural livelihoods. Next slide, please. Now, the World Bank Group is publishing the inventory as a discrete report that you can download and share with your colleagues. The report contains additional background information, explanation of the methodologies that we used, as well as the innovation profiles on key farming systems and technologies in the Artemia aquaculture sector. So I encourage you to download a copy as it is made available. The core inventory aspect is also available as a searchable online database hosted by the International Artemia Aquaculture Consortium. You can access the database on the Consortium website at the link below, and I would like to thank the World Bank Group for allowing us to make use of the data. The online version uses the same tags and categories as in the report. You can filter the database by region, state, sector, business interest, as described before, or browse alphabetically, or conduct a free text search. And the Artemia Consortium will also update and expand the online inventory on an ongoing basis. Next slide, please. And that's all I have for you today. Thank you.
Thank you very much, Simon. And this is online, so I really encourage everyone to if you want to find out who's doing what in Artemia across the world, then here's an inventory for you. And thanks so much, Simon, for explaining that, and for NACA for hosting this important resource for the future. We have a couple of questions. Let's just try a couple of questions before we hear more from the country case studies. Maybe one from the Philippines, and over to you, Patrick. Was there a case study done in the Philippines? You have any comments on Artemia in the Philippines?
Well, surprisingly enough, the very first demonstration of pond production of Artemia was in the Philippines back in the late 70s. But there has been apparently no further take-up of Artemia production, although there are many salt ponds and small salt lakes. But no case study could be done there.
Right, thank you, and thanks, Eliza, for the questions. Philippe, one for you. Given the potential for Artemia for beyond current uses for food and feed, what practical solutions do you think there are for really increasing production of quality and affordable biomass?
Biomass or cysts?
Biomass and cysts.
Okay, on the biomass side, I will drop the ball to Patrick, because on the cyst side, I can be more precise. And I think in the first place, many of the natural lakes that are being exploited do not use sustainable harvesting practices like has been developed at the Great Salt Lake with the Great Salt Lake Cooperative and quota systems in Russia. So I think there's still lots of opportunity to improve sustainable harvesting at the current natural lakes. That's one thing. Second thing at the source side is that there's still a lot of lakes out there. Today, we have not found any that is really at the state of initiating any type of harvesting. But we have seen, and I could briefly show some examples of lake that have massively produced Artemia and then went extinct. We have seen lakes that did not produce Artemia, that developed salinity and produced massive amounts of Artemia. So there's no reason to believe that there would not be other lakes outside there that could add product harvesting capacity for adding to what is available now. So this is also something like
someone has their microphone on. Please switch off if you're not talking. Back to you, Philippe.
Okay, so just what I was mentioning is that at least someone should continue the Artemia task force efforts in scouting for such lakes, see how they evolve, monitoring them, and then decide and find ways to exploit them according to sustainable harvesting procedures. So that's one thing, adding more supplies. But I think at the same time, at the user side, we could do a lot of things to make a better use of the current stocks and the current resources of Artemia. Better hatching procedures, because Artemia has been used now for 50 years in the aquaculture industry, and still we see that even at bigger hatcheries, there is still room for improving the yield that is being produced by improving hatching procedures within the farms. That is one thing. Second thing that is underlined is the use of lower grades of Artemias, is because most hatcheries are using higher grades of Artemia, but still there's quite a few fraction of lower grades Artemia that can be valorized. Today, that's done by companies that are specializing in hatching these lower grades and bringing them to the market in the form of a paste. But also bigger groups can install infrastructure to do the same, use low grades of Artemia and produce the nuclei inside their operations. So I think that is another thing that could save on the potential of producing Artemia in the current resources. And then definitely also making the best trade-off in using less Artemia with more high quality replacement diets. And because there's no other way, we will need to use less Artemia for producing more shrimp. But there is a real risk, and we have seen that risk at large scale, that when going below certain threshold levels, then the quality of hatchery success is going down. So in brief, like I said, we should make better use of the current Artemia resources, but at the same time also secure more consistent supplies, be it in lakes or in controlled productions, like was explained earlier.
That's all right. Thank you, Philippe. That was a really insightful answer to that. And Patrick will come to the biomass question separately. But what we're moving to now is some sort of rapid fire country case studies. And I think we have Professor from the Cantor University in Vietnam. Professor Ho is the head of the Department of Coastal Aquaculture and has been working for many years, and many of those, I think, in collaboration with Ghent University and Patrick Sorgelus on Artemia. And he's also been sharing that experience from Vietnam widely across the world as well. Professor Hoa, are you there, please?
Yeah, I'm here. Can everybody hear me? Can you hear me?
Yes, keep speaking loud. I think it's a little bit
okay.
quiet.
Yeah. Okay. To continue with the country case study, I would like to share the experiment for aquaculture in Vietnam. So, but I suppose that someone will help me to show up the slide. Right? Next slide, please. Okay. Actually, that I'm going to make a long story short. For those, if you really want to engage with Artemia culture, then you need to go for technical basic steps. But in fact, they are including of three main topics. The first one is site selection, system design, and pond construction. The second is pond management and nutritional requirement of Artemia. This is the key word for the pond culture. And then the last one is the seed collecting, processing, and reservation, and then processing under standardized conditions. So each step we need to do carefully, and also to make sure that we meet on the requirement of Artemia, really that you want to stable for the pond production. So next slide, please. So in Vietnam, everybody know that we have no natural Artemia. But thanks to the collaboration with Ghent University, especially with Professor Patrick Sorgelus, so Artemia had been introduced already 40 years ago, and from then on, the culture production system have been developed in Vĩnh Châu and Bạc Liêu area. And after 40, 50 years until now, the area they could produce up to 20 or 30 tons, which have been covered almost several hundred hectares, or sometimes up to 1,000 hectares, with almost 2,000 jobs. And now they can bring up almost 20 or 30 tons of finished product. And like the information from Philip Leger, we are now produced with excellent seed quality, where they can meet on the requirement of stream of fish larvae. At the meantime, we do also for biomass culture, but it's not very much pay attention like seed production. The farm culture in Vietnam nowadays, there are complete protocol or procedure which can help to sustain the production in the area. And the technical has been transferred successfully also to another country. So when I have heard the information that for the next 5 years, 10 years, we may require up to 4,000 or 5,000 tons of seed, I do believe that with the pond production system, like different countries now involved, for example, in Iran, I saw my colleague there, and also another country who are very successful with that. So I have a roughly estimation. If you really need a figure of up to 4,000 to 5,000 tons of Artemia seed in the year to come, maybe you need another 1,000 square kilometers. So I think it's much smaller than the area that you need to exploit in the natural lake. So of course, it's just the estimation, but I think later on we have to face with different challenges and different technical concerns before we can end up with such production a need for aquaculture requirement. Thank you very much. So that is for my presentation.
All right, thank you very much for the insights from Vietnam. That's a fantastic case study and example of what can be done, and the value of the cysts from that system are particularly high. And your calculations of the areas needed, though, I think point to some of the resource challenges for the future as well. Anyway, thank you for that, Professor Hoa. And I would now again encourage everyone to put questions into the chat, but move to our second country case study, this time from Bangladesh. And Dr. Mohammed Mizanur Rahman, who's an aquaculture scientist with Willfish Bangladesh, long experience of working on aquaculture in Bangladesh and other countries in Asia, and been heavily involved in the Artemia development, piloting work in Bangladesh. So, Dr. Mizanur, over to you, please, to talk us through this Bangladesh case study. Thank you.
Thank you, Mike, and thank you, everybody. Also, very nice to see Philip and my friends and of our team and all over the world. This is really nice pleasure and to see all of you on this global context of our team. So, next slide, please. Yeah. So, integrated Artemia and salt farming. Pilot has been done, actually led by World Fish and funded by EU, and this was done in Cox's Bazar in southeastern Bangladesh, where about 50,000 salt farmer families are living. So integrated Artemia and salt farming bring the scopes of Artemia cyst production, biomass production, even aquaculture and vegetable production. Those we will see in the next slides. Thank you. Next, please, next slide, please. Yes. So when you produce Artemia biomass, mostly live, also you can use frozen, but live Artemia biomass in the Cox's Bazar hatcheries, you can sell it for the brood stock diet, or the shrimp nursing in the salt farms, can be used for crab nursing, was also used, and then Artemia as a human diet, which Monica has also explained, and then ornamental fish industries are also now growing, particularly in the urban areas, and many aquarium shops have been buying live Artemia biomass, both live and frozen form. So all the experiences has been explained in the previous slides. We try to implement in Bangladesh. Please move to the next slide. So when we try to do integration in the salt farms, we try to maximize the use of the resources the poor salt farmers has. So when even it can they can produce shrimp nursing and shrimp grow out in the salt farms together with when the salt farming season are going on, playing with the salinity. When Artemia is produced in the dry season, in the rainy season, with the salinity goes down, they can produce tilapia. You see the middle slide. And even most salt farms are used in the rainy season for the traditional aquaculture, but introducing by tilapia nursing or even shrimp nursing, you can increase this productivity. So the project was trying to introduce Artemia and aquaculture for the salt farms. And when we do the integrated salt farming and aquaculture, there are many species, like you see the third slide, photographs. Here you see the shrimp, crab, tilapia, even marine fish, even carp can be produced depending on the salinity of the ponds. Thank you. Next slide, please. Yeah. So the Artemia pond dikes can be used even for vegetable production. Here you can see the different forms, because many poor salt farms are very nearby to their places. So using the pond yards, they can use for vegetable production, and this actually mainly done in the rainy season, because at the time the salinity decreases. Move to the next slide, please. Yeah. The concentrated seawater, which is called brine, is a very nice source for good quality seawater. And good quality seawater is very much essential for the shrimp nurseries, crab nurseries, even for inland hatcheries. So the salt farmers can supply good quality seawater. You see the people are carrying this to even for the shrimp hatcheries in Cox's Bazar, because during the rainy season, the salinity of even the bay decreases, and then it is also because of the water flow, the water quality deteriorates. At the time, the salt and even the brine water is very good quality seawater for them to the hatcheries to operation. Next slide, please. So in a nutshell, this is actually the combination of all the interventions. In a nutshell, the integrated salt and Artemia production, what it achieved, you can produce Artemia cyst, Artemia biomass, tilapia in the Artemia ponds. It can increase at least double of their income, because you have several crops, and then it also bring an advantages of year-round production, so the risks are minimized. If your salt production is hampered, you have many other crops, and you have aquaculture. So that's actually gives a big hope for the poor salt farmers and coastal areas of Bangladesh. I think this model can be copied in many countries in the world. Next slide, please. Thank you very much.
Thank you, Mizunu, and that's an amazing example of just integrated into the coastal ecosystems and food production systems. Thanks so much, and I think your vision of being able to extend that to other countries in the world is a wonderful vision. So thank you for that. Our next presentation, case study from Thailand, and I think back to you, Simon, to talk us through the biomass farming in Thailand. Simon. Have we got Simon?
Oh, sorry, I got that. Next slide, please. Okay. So thank you, Mike. In the case of Thailand, Artemia production is currently focused on the farming of biomass, not cysts, so it's a little different. To summarise the background, Artemia does not naturally occur in Thailand. In the 1970s and 80s, the Department of Fisheries promoted Artemia cultivation for cyst production in solar salt works bordering the Gulf of Thailand. But after a while, the industry shifted to biomass production instead. The reason for this is probably because there was a ready market in terms of local aquaculture hatcheries, and the cash flow is also better because you can do a daily partial harvest of the pond, so you have daily income coming in, which is very attractive. Today, aquaculture hatcheries are still the major market for biomass, mainly for shrimp, but also for marine crabs and finfish, mainly Asian sea bass, and the biomass is sold both live and in frozen form as blocks. So farming practices in Thailand may be divided into two major systems. Semi-intensive biomass production, usually conducted in salt pans, which are shallow with a very large surface area, and intensive biomass production in ponds, which are smaller and deeper. And the depth is an important difference. Because salt pans are shallow, around 60 to 80 centimetres, it is difficult to maintain an adequate salinity for Artemia during the wet season when you have a lot of monsoon rain, so they may not be able to produce all year round. Ponds, by contrast, are deeper at 1.5 metres plus. They're usually former shrimp ponds, and with a smaller surface area, it makes it much easier to maintain salinity in a working range and produce Artemia all year round. The ponds are easier to manage and harvest because of the smaller area. For example, in a pond, you can automate harvesting by using a paddle wheel to direct flow into a fixed net in the morning when the Artemia congregate near the surface, while in a salt pan with a much larger area, the harvesting is much more difficult and you need to use different gear. Artemia are indiscriminate filter feeders. In both the semi-intensive and intensive systems, the Artemia are fed by fertilising the water to stimulate a bloom of natural phytoplankton and halophilic bacteria. The ponds are fertilised using off-the-shelf agricultural waste products such as chicken manure, cassava residue from Ajinomoto production, and molasses, depending on what materials are locally available and their cost. The farmers can gauge water quality by eye based on their experience and amend as necessary, but essentially the biomass farms are using sunlight and fertilisation with low-cost agricultural wastes to produce a high-value Artemia biomass product. The biomass farms are zero discharge. They don't release nutrients to the environment. In fact, the main issue for the farms lies in finding enough nutrients to feed the Artemia pond. We've seen one intensive farm where the Artemia pond is integrated into a shrimp hatchery's closed-circuit water treatment system, and the Artemia pond is used as one component of the water treatment system, converting nutrients from the hatchery into an income stream, while also providing a reservoir of brine that can be used to adjust the salinity in the hatchery. These systems are very productive, and the production costs are exceptionally low. Semi-intensive systems are producing on the order of 0.9 tonnes per hectare per month, while the intensive pond production is around 4 times higher at 3.3 tonnes per hectare per month, with the capacity to go significantly higher. The production costs for both systems are around 15 US cents per kilogram, and the packaged biomass is sold at around, or it ranges from about $1.17 to $1.80 per kilogram. And the profit margins range from about $1,000 to $1,600 a tonne. For both systems, the labour requirement is very low, with a single part-time worker active for 2 to 3 hours a day to manage the pond, harvest and pack the crop. At present, there are around 20 farms producing around 250 tonnes of biomass per year, and we know that Artemia biomass is a high-quality protein source. If it proves to be economically viable to offset fish meal use, we believe there is a very large opportunity to scale up production for use in livestock feeds, amongst other things. In summary, the advantages of biomass production in Thailand are daily partial harvesting, generating strong continuous cash flow, very low input costs as there's no direct feeding, just fertilisation, low labour requirements, and the Artemia continuously self-recruit, so there's no need to restock. The systems seem to be quite low risk with no reported disease problems, and the Artemia life cycle naturally allows them to escape and rebound quickly if there are any environmental issues. It's a profitable and sustainable aquaculture practice with a lot of potential. I think it's quite likely that production costs could be lowered still further with larger scale farms, although they are already very low. And intensive systems, we know from historical data that they can be run at significantly higher yields than they are at present. Thank you.
Thank you, Simon. And those low production costs for biomass start to make it look very attractive as a animal protein source, quite competitive with some of the other sources. And you mentioned fish meal, so wonderful to explore that further. But very, very tantalizing potential there. Thank you for that. Maureen Makami is going to tell us about Artemia in Kenya. And Maureen is a senior mariculture research scientist from the Kenya Marine and Fisheries Research Institute. She's been involved for a number of years in Artemia projects in Kenya and neighboring countries. So Maureen, big welcome today. Looking forward to hearing what you have to say about Kenya. Thank you.
Thank you for the opportunity to speak about Kenya. So I'll just go to my slide. I just have one slide, and I'll highlight Kenya's experience in Artemia farming, both cysts and biomass. And because it's a growing sector, maybe I'll explain about how it's enhancing the blue economy, empowering coastal communities, and also with a possibility of positioning Kenya as a regional leader in Artemia farming in Africa. So under the business model, Kenya, first of all, Artemia was introduced in Kenya in the 80s because Artemia is not endemic to Kenya, but it was introduced in the 80s, and it's at that time when aquaculture was starting to develop, and especially in the marine sector. And so once it was introduced, the Artemia stayed on in the waters, and to date, Kenya has adopted an integrated salt Artemia farming because it has a symbiotic relationship. Artemia being in the salt ponds has a symbiotic relationship with the salt farming because it helps to clean and the salt and also increase the quantity. And at the same time, also there's an aquaculture aspect that is incorporated in it, because when during the salt production period, the salt is produced together with Artemia. Then when it starts raining, someone please mute. Grace, please mute. So during the rainy season, fish is also stocked in the ponds, and so there is that. The model is salt Artemia aquaculture. So it combines all that, and this helps to diversify incomes and maximizes the use of the saline resources, thus contributing to both economic and environmental sustainability of the salt sector. So in terms of the production, based on our research that we have been doing over the years, we have realized that 1 hectare of a salt Artemia farm in Kenya produces 250 kgs of biomass, and also it has a capability to produce also 33 kilograms of Artemia cysts. That means it generates about $3,000 per production cycle. And this demonstrates that Kenya has quite a potential of scaling up Artemia, because we see because it's usually produced in the salt farms. The salt farms, the artisanal salt farms, the list is about 50 hectares. Well, for the commercial salt farms, we have commercial salt farms with areas of between 3,000 hectares to 6,000 hectares. So there's big potential if only a few things are sorted here and there. And in terms of socioeconomic impacts, 40% of women have benefited in Artemia farming, and because out of the 350 direct beneficiaries, we have 2,000 indirect beneficiaries who benefit from this farming, and most of them are women and children, the indirect beneficiaries. But for the 40% women, they are involved in salt, in the pond management and pond construction, as well as salt harvesting. And this shows that Artemia farming is not just an aquaculture venture, but it's also a tool for community empowerment, gender inclusion, and livelihood diversification. And then when I go to the market, the market opportunities, currently in Kenya, we are getting more of imported Artemia that is being used in the hatcheries, while about 10% is being used, that is produced locally, is being used in aquaculture. And this shows that there is a significant potential, because if you're getting over 90% of the Artemia imports, so that means we have great untapped potential in Kenya to develop sustainable Artemia supply chain for both local hatcheries. And right now, we have hatcheries that are currently being established in the Kenya Marine Fisheries and Socioeconomic Development Project that is supported by the World Bank. And those hatcheries we will also be expecting to use Artemia in mass, because they are modern hatcheries. So we expect that we will have a lot of demand for Artemia in those hatcheries. And also Kenya is also poised to, if we can produce in mass, we can also be able to sell to the regional markets in Africa, despite also having Tanzania and Mozambique also producing. But that shows that we have a regional production. We can produce Artemia regionally, because this has been tried in other countries. And then in terms of I just want to say that the imported Artemia apparently costs very high. When we were doing this study, I realized that when I was calling the people that sell Artemia, they were telling me that they are selling it at, the farmers, the hatchery or managers that buy the imported Artemia, they buy it to a tune of about Kenya shillings, 35,000 to 40,000 shillings. That's about $300 per kg. And I think it's because of the shipping cost and all that, while we who are producing locally are selling it at about 7,000 Kenya shillings, which is about 55 USDs. So that shows that if we produce it, we can try and reduce or provide a better price for the local market. And we expect that we have a shortfall of about 200 tons. So if Kenya can, because we have been consistent in production of Artemia, though in small ways, but in case if we improve if we scale up our production strategically, we are able to become a key supplier in Africa. But we are also facing our own challenges as we produce Artemia. And one of the challenges is we have limited infrastructure, we have weak policy frameworks, we have inadequate specialized Artemia farming inputs. Like we bought an Artemia cyst processing machine, but from Vietnam. Sometimes you look for even what are they called? Salinometers, and you cannot find them in the shops because they are not. We don't get them. We don't. There's not much that happens. Like salt production only happens in the coastal region, so we don't have this equipment. You cannot easily find them in shops, and also the issue of market linkages has been a problem. But we are lucky that we have been able to build a wealth of experts in terms of research and at the community level for Artemia production. So that means we have the expertise. So once we are able to go through the challenges, we can be able to unlock the investment potential for Artemia in Africa. And in conclusion, I would say that Kenya's Artemia journey reflects resilience and a growing opportunity to realize its full potential in the blue economy. And by strengthening policy support, capacity building, and strategic partnerships, Kenya can lead Artemia production in Africa, driving job creation, food security, and sustainable growth. Thank you.
Okay, thank you, Maureen. And yeah, that's another very strong vision for the future there. Thank you for that. And also emphasizing the importance of getting the market right, and also the socioeconomic impact and opportunities here for Artemia integration into coastal areas. So thank you very much. Moving on, our final country case study from China. I think we have a video, but from Professor Liying Xu, who's a professor at Tianjin University of Science and Technology in China, but also, importantly, the director of the Asian Regional Artemia Reference Center. Liying, I'm not sure if you're with us or we're going straight to the video. Maybe over to you, Vivek, for the video. Liying, you're not here. Yeah, I saw you earlier.
Right, I'm in the meeting, but please just put the video on.
Okay, all right, you are there. Thank you so much. All right.
Yeah.
Great.
I am Sui Liying. I'm from Tianjin University of Science and Technology. I'm also the director of Asian Regional Artemia Reference Center. Today, I'm going to talk about Artemia production in solar saltworks in China. Being a leading country in global aquaculture industry, China has the largest demands for Artemia, with annual cyst consumption reaching 1,000 to 1,500 metric tons. Apart from the local Artemia resources, China imports large quantity of raw cysts from Central Asian countries and Russia. China is also the biggest cyst producer in the world. In China, Artemia are marketed in different forms: the full cysts and decapsulated cysts, the fresh and frozen biomass used as feed for shrimp nursery and grow out, as well as for the ornamental fish. In some regions, live Artemia nuclei are also produced in so-called Artemia hatching workshop and sold to the neighbor shrimp and fish hatchery. The declining in wild cyst harvest from inland salt lakes in China has resulted in price fluctuation of Artemia cysts in local market. Fortunately, the situation can be compensated by the high productivity and stable production of semi-intensive Artemia farming in vast salt ponds in Bohai Bay coastal area. The annual production is up to 600 tons of cysts and over 100,000 tons of biomass. Particularly for biomass, it accounts for over 90% of global Artemia biomass production. Socio-economic-wise, the proper integration of salt and Artemia production has not only positively impact on the water quality through Artemia filtration, but also provides many job opportunities for local people. In China, Artemia production are mostly operated by salt companies. Besides of benefiting from Artemia production, the salt farmers also learn more knowledge on ecology and realize the importance of biological management on the salt production and quality. Recent 20 years, along with the extensive farming of white-leg shrimp, Panis vename, in low salinity ponds, the salt farmer are more and more involving in aquaculture business. Compared to the other country, the Artemia production in Bohai Bay area has its own advantages. This region is very much industrialized and highly populated. Thus, the brine is in salt works is considered eutrophicated. The Artemia farming ponds are usually large, with stable salinity and high nutrient content, which is ideal for Artemia production. The farming is mostly operated in the existing ponds, thus the production cost is usually low. It has also efficient value chain. Nearly 100% Artemia cysts and biomass production are integrated with shrimp farming and salt production. The company also has its own processing facility and marketing teams. But there are also some advantages, such as increasing environmental pressure in the coastal areas. For example, the acidification of brine water due to the bromide extraction, the declining production areas due to the urban industrialization, and also more regulatory supervision over water quality, which challenges the fertilization strategies of Artemia ponds. For more details, please see the video clips later on. Thank you very much.
Okay, thank you, Ying, for that. That was very insightful, short case study on a major development in China. So thank you for that. We have 15 minutes left. What I propose is that we come back to some of the questions, and thanks so much for those that have commented on the presentations, put questions into the chat. I'm not sure we'll be able to get through all of them, but let's try, and let's also throw one or two additional questions in, because we want to look into the future as well. I wonder if I could just first pose a question to Patrick. You can see this quite diverse, high potential, new applications, diversity of production systems. What's your lesson? What do you think the lessons learned from across the different countries and regions at the moment about the future of Artemia?
Yeah, I will try to give a short answer, because that's one way we could really elaborate. Well, first of all, I think, and it's clear from Philip's and other presentations, we need to make a proper inventory of what are the natural Artemia sources, because some are exploited, many others are not exploited. Which areas, and then I'm particularly thinking about Africa, where there might be potential to introduce Artemia, to do first the proper analysis on environmental issues. So, okay, inventory of existing and potentially new places. Second, Artemia biomass production. I think what we have learned in this study, particularly with the detailed economics of the production in Thailand, Central Asia, and I'm going all the way from central western part of China into southern Russia, Kazakhstan, Uzbekistan, where there are several million hectares of salt-affected agricultural land. We don't have the time here in this webinar, but Uzbekistan is one of the first countries where they have demonstrated the possibility to grow Artemia. So a very good example of circular economy in areas that are lost for classic aquaculture. And then the last one, coming back to what Philip was also saying, we need to look into a better use of Artemia, better use in terms of how the product of high and low hatching quality can be better used, more biosecure use, because a lot of the diseases in hatcheries are caused by inappropriate use of Artemia cysts. So I think I should stop here.
All right, thank you, Patrick. I think that touches on the biomass question that came up earlier. How do you see the future of biomass, Artemia biomass?
Yeah, well, with the example of Thailand, where until now it is only applied in aquaculture, we have seen the first examples in Bangladesh. We have recently also seen the first example in Uzbekistan, where Artemia biomass is even used for chicken farming. Recall the presentation of Kartik and the work that has been done in Iran. So for the next decade, I see a real expansion of Artemia biomass production linked with improved uses in aquaculture, but particularly also as an opportunity to grow animal protein that can be used in aquatic as well as terrestrial animal farming. And the work that Manika has explained about potential incorporation in human recipes.
Okay, thank you. Harrison, could you tell us a bit more about how you see Artemia from the World Bank? How do you see what are the entry points for the World Bank for future investment in Artemia, and how does it align with the World Bank priorities? And I don't know if you're able to, but there's a question on blue carbon credit mechanisms that would be fascinating, I think, to learn more about. But Harrison, how do you see this from the World Bank perspective? Look into the future.
Thank you very much, Mike. I think you caught me on a very wrong footing because I didn't expect you to ask me a question. Anyway, you have done it already. So, well, I mean, as far as I'm concerned, this is a new thing for the bank, totally new. I think you heard from Tuka when that he has had it for the first time since this study started. So it is very new to most of the bank people. And it's one of those things that people are discovering as we go along that is very, very important for what we are talking about in aquaculture. In our recent past, we have produced the Aquaculture Digital Roadmap that is basically trying to enable the World Bank to see the opportunities that we have in aquaculture development. So as a cog in the wheel of aquaculture development, I think we are seeing the future of Artemia to be very, very important, especially since some of the donor community that is helping us with the blue economy is now focused much more on mariculture. So as mariculture is getting developed or getting focused upon, we cannot afford to not see the role of Artemia in that future. So I think we are all out looking for whatever we can do. And you can see also my questions have been on how we can increase the biomass. It's very important that it's also touching on quite a number of our SDGs. This about food, about livelihoods. It's touching on also climate change as well, because I mean, as we go forward, the climate is getting more and more, unpredictable and also warming up. This is obviously a commodity that will be very useful for the world that is changing in that way. So I would say that the bank is really out to develop this, and we are looking for opportunities for investments in every corner of the world. And I was happy to hear Philip mentioning here about the opportunities that we can actually get some natural lakes also coming in. And also to hear all the presentations and Patrick have been here telling about how the consortiums that have been developed around aquaculture can actually contribute more and more into this. So I would say, also from the story that we have had here, I don't want to make too long. Country case studies are very important because they help us to understand what others can also do to develop their own sectors. As has been very clear, I think from Maureen's presentation as well, many countries have been trying to do this and not succeeding. So we want to see what are the gaps that that can be filled to ensure that countries can partake of this. And I believe that the team that has presented today will be very, very important going forward and ensuring that the bank can take advantage of this. The question on carbon credits and so on, and reduction of carbon. This is obviously very new in the game. We need to learn a lot of things as well on how Artemia can be part of the lowering of carbon footprint. But I would say that, again, the role would be, not even if it's not directly, the fact that we are talking about aquaculture that is really very low on carbon footprint will tell us already that there's some, contribution that Artemia can do. But I would also think that the science might be required to go through to see means and methods of producing Artemia without increasing carbon footprint. This will be something very, very important to also see, to look at the culture system that Artemia happens to be grown in. Back to you. I think I can continue, but I think this is the gist of what this is all about. Thanks.
Okay, all right. Thank you, Harrison. So we've got 6 minutes left to close the meeting, and this final part was looking at ways really to try and wrap up the sort of future direction. I think there's a tremendous diversity of insights, but what's coming through very strongly is the potential of Artemia in various ways. A number of challenges, both in conservation of the and management of wild stocks and pushing production forward through sustainable aquaculture. I really enjoyed the cases from Africa, Bangladesh. The cases were great, both showing the opportunity, the socio-economic impact, the possibilities of farming, the possibilities of more efficient protein production, the nutritional value of the product that we're working with, which is really likely to open a lot of very important doors for nutrition of humans, perhaps better feeds, as well as sustaining the aquaculture industry in many of the traditional ways. So big thanks. I think we didn't quite manage to address all the questions. I think everyone's very open to keep the networking going from this meeting. I know the bank is, and perhaps you can just say a few words, Harrison, to close on the next steps. But I know you're very keen to keep the momentum, the networking, the knowledge exchange going into the future. And I think we're all in the team very keen to work with you and to make that happen. This has really been an eye-opener, and I think perhaps particularly hearing Patrick saying that after all those years of working on Artemia, the past year or so opened his eyes to many future opportunities as well. It's a good point to finish. Thank you very much for all the presentations. Thanks for all the participation and questions. Thanks for everyone's patience with a little bit of the digital glitches. And thanks so much for the opportunity to be with you all today. Pass back to you, Patrick. I think you've got 3 minutes to close the session on time. Thank you.
Or Harrison.
Harrison, sorry.
Okay. Well, Patrick, you can always say something if you want, but I mean, I can, because we have so much little minute, I will not talk too much. I just want to really take this opportunity to thank all of you for active participation. I mean, this has been a 3-hour event, and to see that we are still here, it is already a testimony of how committed we are to getting this thing done. I don't have the time to mention all the presenters by name, but I just want really to really thank all of you for presenting very passionately about this little commodity that we are looking at. And I also want to really thank you, Mike, for the very good moderation that you have done. I think it's very fantastic that you have managed to go through it, even though we even had a lot of issues with, of course, in some of the presentation, but we soldiered on and made it very nice. So again, as the learning brief event name says, farming resilience, unlocking the Artemia opportunity. I think we have also been very resilient in making sure that this works. So a very, very good, thanks to all of you. As we have heard from the global experts and stakeholders, Artemia continues to play a very vital role in sustainable aquaculture, food security, and economic development worldwide. I think the opportunities for innovation, investment, and climate smart solutions are very, very big. We have seen them. It's we are scratching the surface in one way or another. From the integrated production systems to the value-added processing and food and job creation that can be done can happen in coastal communities. I think we are looking at a very good opportunity that we need to focus on. As I said in my earlier remark, I think one thing that we need to see is more investment coming into aquaculture of Artemia, because it has the effect of touching on many other things, like, Artemia can touch mariculture development, can touch food, can touch jobs. Also, we know that there's people who are in these communities can make more money when they do Artemia. So I think in a way, we have all the responsibility to push this forward. And I would just end by saying that let's carry forward the insights and the connections that we have been making today and always to advance the responsible Artemia production and conservation and ensure resilient aquatic food systems for the generations that are coming. I also want to thank ProBlue for making this happen by funding this exercise. I also want to thank the team that has not been mentioned, Diana Ferozovic, who has been in the background, Vivek Prasad and Ruth Garcia have been very active organizing this thing. With the Future Fish team, all of you, the Artemia Consortium, really appreciate it. And lastly, I just want to welcome you because, again, we are having a meeting in India for those who are traveling at the World Aquaculture Society meeting. On the 13th of November, we will be meeting to have a full day of a discussion on Artemia. So we are looking forward to meeting you there. Thank you very much, and God bless.